Hi, everybody. My name is James Densmore. Really excited to be here today to talk about two of my favorite things, open source software and the modern data stack. Before I get started, there's a QR code on the screen. You can scan that. You can get into the Discord channel where there's a live chat. So I'll give you a second and then I will get going. All right. So first, a little bit about me. I'm currently the Director of Data Infrastructure for Business Intelligence at Hubspot. What that means is I lead the engineering organization that is the central data team for HubSpot for internal analytics. So I'll get into some data team structure and things around the modern data stack later. But what my team does is we have data engineers, data warehouse engineers, and software engineers really focused on the infrastructure and platform that analytics engineers and data analysts are building off of. So, data pipelines for data ingestion, orchestration, as well as some data warehousing for kind of core data assets in the company. Again, talk a little bit about sort of that distributed data team model later on, but it's a lot of fun. I'm also the founder and consultant at a company called Data Liftoff, which I started a few years ago. I did that full-time for a while. Now I do it on the side when I have some time, working full-time, of course. And then I'm also the author of a book that came out this year called Data Pipelines Pocket Reference. You'll see the friendly animal logo there. It's an O'Reilly book. If you haven't checked it out, I'd love if you did, give me some feedback. It's been a lot of fun writing it and hearing from people who have read it. So please do. And with that, first I want to talk about what the modern data stack is. So, we're going to talk about it a lot over the next few days. And I took this graphic right off the conference homepage. So hopefully you've all seen this. And you're going to get to hear from all these different open source products and projects along the way. But when I think about the modern data stack, I think about all these different pieces, collecting data, bringing it into a warehouse, transforming it, orchestrating all of those jobs that are doing so, visualizing it, and then more recently syncing that data for operational use out of your data warehouse. So I'm going to go through a little bit about, how this all fits together and how open source plays such a big role in the modern data stack as we go through. But before that, I'm going to back up a little because getting to what we consider now the modern data stack in 2021, it's taken some time to get here. So I'm going to go back about 10, 15 years and talk about how we got to the point where this is even all possible and why there's such an explosion of great tools that are coming out now in this stack. So going back, probably, I guess, 10 to 12 years now, most of us, if you were around during that time in analytics, you were building data warehouses most likely off of a row store database. So an OLTP database such as MySQL, Postgres, and so on. And those are great databases for application development, but that's what was around. So we sort of had to work with row store. At the time, I would guess that most of us, at least myself at that time, didn't really think about that so much, right? We just said, this is a database. I can write SQL, I can build tables and write scripts. That's great. I can, build a data warehouse and I can report off that and do all these great things. Unfortunately, it wasn't designed for that. And it makes it harder to do the analytics work that we all do today. So this is probably the most technical slide in the entire presentation. So I'll dive a little bit into it, but it does get a little less technical from here. So row-based, just as the name would lead you to believe, data is stored row by row on disk. So in this example, it looks like a customer record. Of course, this has a social security number, not a real one, but you probably never want to store that in free text. But as an example, you have a customer record. Each record is stored in a block, if it fits in a single block, on disk, so together. This is really optimal for applications that are going to read and write, small sets of records, and likely either all or most columns in a record. It's very efficient to get to all of that at once. So you can see in the example there, a single row is kind of highlighted on block 2 of that disk. If you want to read that and write back to it, it's great. It's all right there. It's very efficient. However, when you think about the tables that you're building in a data warehouse today, they're very wide and often very deep. So if you want to read an entire record for, just like exploration, you're probably fine, although it may be wide enough that it spans multiple disk blocks. But you're also not typically reading or writing a single record. You're doing a lot of bulk work. You're either bulk loading data in, you're selecting a large amount of data and then aggregating, whether it be summing up or averaging, joining massive data sets, but you're often doing it just a few columns together at a time. So that's where column or store databases came in. You see the bottom image there, same table, same records, but we're storing data column down. So in this case, social security numbers, all stored together, names, ages, etc. And so if you think about writing a query where you're looking at, instead of one record, maybe tens of thousands or millions of records, and you want to get the average age, for these customers, now you only have to read down, that age column, and those are all stored together on disk. Furthermore, this makes it easier for data distribution across many nodes. When you think about the fact that we can, cluster and store data by column rather than row for analytics purposes, you can kind of pick and choose, which data needs to be together and then break it up in a more efficient way. So that was a big change. And it's something that all the data warehouses we're using today are column or store for data warehousing for this reason. The next thing that happened was, believe it or not, when that first happened, all those columnar databases that we were all working with were on-prem. So that really fancy looking thing on the left there, that is a Netezza TwinFin appliance. I actually worked with one of these. It was one of the early, columnar sort of MPP or massively parallel processing data warehouses. And it was a total game changer. Performance-wise, you could do things that you just couldn't do on those more traditional row-based databases. The downside was you literally had to get those appliances into your server room, set up, running, maintain them. And if you wanted to scale up, you literally have to order more hardware and put it in place. So really cool appliance, very expensive. Not every company could afford them. Not every company could deal with maintaining them, and certainly very, inflexible as far as scaling either up or down. So, learned a lot from those, but what came out of that a few years later are cloud data warehouses. So the first one I worked with was Redshift. Now we have Snowflake and BigQuery and others. That change was massive. That took that same technology, made it affordable, accessible, scalable, and, really open to a lot more companies working with such databases and data warehouses. So if you think back to, I know now it seems crazy to even consider that kind of hardware investment. But, at the time, data teams are just kind of coming into, I guess, prominence at companies. So you're not necessarily sitting there with a large budget to start with. And now you're saying, I have to go out and buy physical hardware. I need to upgrade it and maintain it. That was very difficult. And to move to the cloud, it was more, hey, I can spend, maybe a few $100s a month to try something out, prototype it, get it up and running, scale it up, scale it down. Not a massive commitment financially. That really opened the door to a lot of what we see today on the modern data stack, which is, new companies right out of the gate building on these, very high-powered data warehouses at an affordable cost. So what all that led to was this big evolution, which really kind of happened behind the scenes for a lot of people, but now seems a bit more obvious. And that's that transition from ETL to ELT. So ETL, extract, transform, load, kind of the three major steps in a data pipeline. If you zoom way out, extracting data from a source, loading it into your warehouse, and transforming it. And the matter of order of those steps really sets the tone for what your data stack looks like and what your data team looks like. So those warehouses, those column or store, data warehouses that you could distribute across many nodes, allowed us to switch the order a bit. So, instead of extracting data and then having to do a lot of transform before loading it into a more traditional database for performance reasons and storage reasons, you could skip that transform and put that at the end. And what that does is it gives data engineers the ability to focus on the first part, the EL or data ingestion, data integration, whatever you want to call it, they can focus there and get the data into a warehouse in maybe a bit more of a raw form, and certainly not have to cut out, and pre-aggregate or anything like that for performance. These modern data warehouses can handle both the depth and the width of those data sets. And so out of that, the transform, and when we talk about transform here, just as a note, there's still some transform in that EL, but not business contextual transform. So, shaping data a bit, cleaning it up, deduping it, sure. That definitely happens during that extract and load now. I consider this like a lowercase t versus the uppercase T in ELT, which is where data analysts fit in. They are modeling data using things like DBT to create data models and actually, derive analytical value from that data. They can completely own that. And you see this separation of data engineering and a data analyst who, has sort of grown into the analytics engineering role that really, to me, only became possible with ELT. And I'll talk a little bit more about analytics engineers. I'm sure you'll hear more about it in other talks. But that role of a data analyst really becoming empowered to own their data modeling, using more of a software engineering mentality and how they work, really became possible first from columnar store, then cloud, and then this sort of evolution to ELT. Those analytics engineers, when I say they're becoming more like software engineers, it's because of the way they work and the tools they use. And some of these tools are very familiar to all of you that are working with open source, using things like Git and other deployment tools that are very popular. Analytics engineers have gone from the data analysts of a few years ago that were very stuck waiting on engineering a lot to get their data, kind of get it like preformed to deploy it to production. They've been empowered in amazing ways, as you'll see with some of the different tools and open source projects, over the next few days. And they're working a lot like software engineers. I started my career as a software engineer. When I moved into data, it was like, we didn't have the same tooling. It was, there were companies that just pushed things right to production. There was limited or no version control. Just that whole concept of unit testing was not there. Maybe people wrote some data validation tests, but they weren't testing their code, as if they were a software engineer. All that is now happening at a lot of companies. And there's a lot of great open source projects that are enabling that. And I also think that analytics engineering role is growing up so fast. And it's so exciting to see how empowered they are in an organization, because they do know the data better than anyone else, at least in contextual sense. And so how does open source fit into all this? Well, like I said, by splitting out, ELT into EL and T, it's not quite that simple, but it does allow open source projects to kind of come in and fill different gaps and different needs. So data engineers are getting their own tools. They're starting to not have to customize everything themselves, or build on top of a single kind of like enterprise development. So a lot of tools for both data ingestion as well as orchestration. All the different jobs that have to run, and dependencies upstream, downstream, coordination. Some great orchestration frameworks in the open source world, as well as data ingestion frameworks. And those analytics engineers, like I mentioned, they are now moving out of the just in a dashboarding tool and moving into being able to truly build out data assets in the warehouse with some of these transformation tools and frameworks. And open source is great because you can kind of pick and choose which ones make sense for your team. And then finally, like I said, at the end of ELT is sort of that, what I'm calling ELT plus, if you'll call it reverse ETL, operational analytics, you name it. But as you're deriving analytical value from data, you do need to sometimes get that into your operational systems. And I'll talk a little bit more about that and where that's trending later. But that's empowering those that know the data, those analytics engineers, to get the data to where it needs to go after the warehouse, which is a relatively new concept. So when you're thinking about open source, like I said, you're no longer stuck in that sort of like single enterprise analytics platform mindset anymore. It maybe not even 10 years ago, certainly when you were at a company of any meaningful size, a lot of times the question is, which BI platform do we go with? And people tried to build just about everything off of that single platform. What's been great about this explosion of open source activity in the analytics space is you can pick and choose the tools you want at each point in your pipeline. So all the way from data ingestion, orchestration, kind of cleaning data, testing, observability, transformation, data visualization, whatever it is, there's a great set of open source projects popping up, and you can pick and choose. You're not locked into this single ecosystem and vendor. And from someone who leads a data team and makes purchasing decisions, I can tell you that is a big relief and something that it just feels lower risk. You're able to experiment and not lock yourself into a long-term relationship with one single enterprise vendor. And now, in addition to that, it makes that build versus buy no longer that binary choice. I've been asked this question several times from people, like, where do you sit on build versus buy? And my answer more recently has been, it's not a choice, it's both now. You are, a lot of us are using a lot of commercial tools, and that's great. Snowflake, Redshift, whatever data warehouse you want to use, go for it, right? And then, layering open source along with other commercial products throughout your stack, that's fine. I have a picture of an old, this goes way, way back, much further than that 10-year span, but, making a mixtape. I could have put a Spotify playlist, but something about physical media really appeals to me. But just that feeling of being able to customize and make something that is really fits someone or some event, right? Like, that's how I think about the modern data stack, is putting things together, building your own stack from what's out there. And open source is just, an amazing way to kind of pick and choose and then customize, as we'll talk about a little bit later. And the last thing I want to mention too is sometimes when people hear open source, they go, oh, we're completely on our own here. That's not necessarily true. There are certainly enterprise versions, supported versions of open source tools. There's also great communities around open source to support. So it's not something that is just, here's some code, go run with it, and now you're completely on your own. That's not true. It never really has been with open source, but even more so on the, in the analytics sense. All these different products that are coming out of open source, do have great support and communities around it, if that's the direction you want to go. So basically, you can build your own stack, and I think that's a really exciting opportunity. So just one example of that, kind of that customizing situation you're in. So at HubSpot, as one example, a lot of our data, most of our data, the majority of it that we are loading into our warehouse comes from internal sources. It's not true at every company. We've been around for a while. We're a software company, so we just happen to create a lot of our own data. And so if you start to think about how you ingest that data, how you might want to get it in, it's very difficult to kind of go off the shelf and get it all loaded in. It's also very difficult to just continue to customize and repeat over and over again how you're loading data in. And this is common with a lot of companies. When I was consulting, even more than I am now, talking to different companies, hearing their problems. Hey, we have so many different data sources. Some are supported by common ingestion frameworks, some aren't. We have engineers who are just too busy to build these things. They break, all that kind of stuff. And that's why you're seeing this explosion of data ingestion tools and frameworks popping up. And with open source, you can customize. So if you do have a lot of custom sources as well as third-party sources, there's these frameworks that you can build off rather than having to start on your own. But also, you kind of come in with a set of connectors that others in the community have built. Some of those are reusable, some of those are extendable, and you can certainly build your own and also contribute back to that project and kind of build up that ecosystem. So when we're thinking about the limitations of commercial products, sometimes they're there, sometimes they're not. But with open source, you do have that ability to always extend and also integrate with the rest of your data stack. So whatever other things you put on your mixtape, you can kind of put these things together and customize, extend, and then again, contribute that back to the project for others that it might be doing something similar. This is a very sort of the complete non-technical side of things. There is a culture that you want to create when you are building a data team. True with any team in a company, But data teams right now, it is a young practice. Everyone seems to be hiring like crazy, as all of you probably know, based on your LinkedIn inboxes. It's a time where you really need to set yourself apart. And I found that open source really does have more of a community, sort of nature to it, and really a great vibe on a data team. So you think about, and I ran this experiment. I talked to people who work for me. I talked to people I know in the industry. And I said, what products are your engineers, your data engineers, your analysts, your software engineers who are working in data? What are they really passionate about? Like, what are the things right now? And just about every example I got was an open source product. Not all of them, certainly some commercial products do a great job of community building. But the number of open source ones was staggering. So you can try this. What Slack communities are they members of? What meetups do they go to? What conferences do they go to? What do they chat about on Twitter? Who do they connect with? There's a lot of open source in there. And that is something that when you are posting jobs, kind of creating that data team culture, you can call out these different things. We work with this open source project. This is on our stack. You can become members of those communities. I spend time in some of those Slack communities. They're very active, and it's not just for recruiting, but for learning, kind of becoming a part of a bigger data organization outside of your organization. A lot of these projects have done such a great job of creating that. And then, I mentioned this before about giving back to open source. There's that ability for engineers not only to solve for themselves and kind of, not feel locked in, but as they are extending and customizing on top of an open source product, they can give back, right? That could be, submitting a PR, maybe it's a bug fix, maybe it's a feature. It could also be, coming to a conference to speak, to share knowledge. Your company might sponsor, some of these different projects. There's a lot of different ways, but again, it's a level of engagement and learning that your engineers and your analysts get that you don't get necessarily when you are fully on the buying an off-the-shelf product. So again, your team might be different. The ones I've talked to really get excited about open source, and I encourage you to go out and talk to your peers and your manager and those that work for you, whatever it may be, and find out, where are they spending their time, and where are they getting excited about, different products. And I bet you there's a lot of open source in there. So I mentioned this a little bit earlier on, but ELT has been that like big thing, right? And a lot of the modern data stack is focused on getting data from a system, getting it into a warehouse, transforming it, visualizing it, making sense of it, creating sort of this analytical value. That's been great. And that has empowered a lot of different businesses to make better decisions. But where are things kind of like just starting to go, and that, to me, there's a few things I'll talk about at the very end, sort of like further down the line. But right now, I'm seeing happening, and we're seeing different open source products and commercial ones pop up around, is this sense of operational analytics. Again, some people are referring to this as reverse ETL because it's data coming from your warehouse back to production systems. There's a lot of different names for it, but I like to think of it as the value that you are creating, that analytical value in your warehouse, can do more than just power internal reporting and analysis and data science and all that. It can go back into various production applications, workflows. And this is something that quite honestly scared me a few years ago when I saw it happening. I think it still scares a lot of people today. The warehouse was never seen as like a production system, right? It was never sitting on the same thing as sort of the application databases as far as infrastructure or uptime or monitoring and all that. And that might still be true in many regards. I personally don't recommend hooking an application directly down to your data warehouse, for live querying. It's not really set up for that. However, there are a lot of cases where analytics engineers are creating, or data scientists are creating value from the data in the warehouse. And then that data needs to go power something in your business. So maybe a marketing email workflow, or something that's sitting in front of a salesperson live on their application as they're on the phone with a customer. In the past, this has happened a couple of different ways. Sometimes an analyst will maybe build a model that has some kind of, value score or something, and we want to give that for lead scoring to sales. They might export that as a CSV, get it uploaded into whatever, CRM salespeople are working with or other tools. And that was the process. Other times, and this is what we've seen in the last couple of years, people will find different ways to automate that process of getting data from a warehouse, to those operational systems. The problem is it wasn't being done in a standardized, consistent, governable way, and things can get really out of control. Someone will be in one of those, production tools and go, how do we get this score? Or how do I know, like, how did this email list get generated? Maybe the person who built it is no longer at the company, all these different things, that it was sort of just behind the scenes. And so this is something I always tell people, if you're not doing anything about operational analytics, you're not using any tools, many of which are open source, or not putting some kind of governance in place, doesn't mean it's not happening. It's probably happening and you just don't know about it, or you just don't have the time to focus on it. But you really should start to take the time to focus. So I believe this is a good thing. I do believe that the analysts and the analytics engineers and the data scientists who are producing this analytical value know the most about it, and we should empower them to get it to where it needs to go. Not have them blocked waiting on engineering, or exporting, flat files and sending them around, or whatever else that might be done. They are the right people. They know the data. They understand the models they've created, the metrics they've created. Make sure we're getting them the tools they need to properly do this, and go beyond ELT into that, sort of next phase of the warehouse actually being a source to other systems, which again is sort of a concept that was just not well established not that long ago, but it's great to see this kind of coming into the modern data stack. The other thing that is really happening right now that is one of those things that, whether you like it or not, it's probably an issue you need to focus on, is data protection and governance. And I say whether you like it or not, because in the past, this has always felt like a nice to have. Data protection was seen as like, well, we need to make sure that our network is secure, and that we don't share social security number, in free text or something. We don't have that in there, and people seeing it in reports. That's all fairly obvious at this point, but we are now at the point where there is a lot of legislation, whether it be GDPR or something else. Customers also, they care more. They will ask, how is my data protected? Who's seeing this data? What are you using my data for? Are you using it for me or for your benefit? Those kind of things, those are not nice to haves anymore. Those are the world we live in. And so thinking about data protection and data privacy is something where I feel open source gives you a chance to own more of your data, where there is some stuff that you might want to keep in-house. And you want to really understand how you're protecting it, how you're governing it. A lot of the open source, projects that are out there are focused on that. People who are not as comfortable sending that off to a third party anymore. How can I own that? Same thing with data governance. When we're talking about observing our data, how's it doing? Is it valid? How do I find things? That is something that there's just so many different open source products that have taken us from a world where, sort of that old method of, documenting your tables and writing manual tests and, data dictionaries that were never kept up to date. That doesn't get by anymore. As I've talked about ELT and the empowerment of analytics engineers, it's not surprising that we're creating more and more assets in our data warehouses every day. Some of those are powering operational, components on the infrastructure. Those old ways of, manually observing and testing and documenting data just don't work anymore. It's a good thing we're creating more, in my opinion, but the downside is, how do we find it all? How do we keep track of it? How do we know when things go wrong, right? We can't expect every manual test to be written and maintained and monitored, right? I've been around places where you do have good tests and alerts, but they're going out to Slack channels or email lists that are not well monitored. All of this needs to be really kind of pulled together, and data governance, I think, is going to be something that we're going to continue to see more and more investment in, as well as data protection, because again, we're at a different stage now. We've grown up as an industry, and it's time to get really serious about investing here. So looking into the future a little bit, and I'm always reluctant to give any kind of bold predictions for the future, especially in a talk that people can watch years from now. So I'll be careful, but seeing some of the trends now and how open source is playing into those is really exciting. And I think we are today and throughout the next few days sitting on some of the bleeding edge of where this is all going. So one thing, I've brought this up several times, especially with the ELT and the birth of the analytics engineer, but just empowering those with the domain knowledge of the data more and more so is going to continue. It's not going to slow down, in my opinion. So as analytics engineers become more and more empowered, with open source tools, with commercial tools, just with their own skill sets, and as they work more like software engineers and can, kind of take their own destiny into their own hands a bit more, I do think that autonomy and independence, A, is a good thing, and B, will continue to accelerate. I mentioned the decentralized data org. So this little diagram at the bottom kind of represents what I mean by that, where that orange dot in the middle is a team like mine, a central data org that is not focused on a single domain of data, marketing data, sales, et cetera, but is focused on the infrastructure and tooling, orchestration, all that empowers all of those other dots, which represent data teams embedded in different parts of the organization, to run with their own data. They understand that data. We want to empower them, but we want to do it in a way that is governable, that they can work together. Marketing might create something in the data warehouse that sales wants to use. How do we make sure that that is supported and done in a way that puts them both in a place that allows them to maintain that and understand what it is? So the central data team really providing that, which I'll talk a little bit more about in a minute. I think that's a big part of it. The last part here is this starts to make, we've talked, I've heard this used, this kind of phrase used a lot over the years, which is data as a first-class citizen. And I think one of the reasons why it's been so challenging for a lot of organizations to really live that is data teams were locked into a single org and either put under engineering or IT or marketing or finance. I've seen it all over. And so the rest of the organization just doesn't, it's harder for them to see and buy into the value of data when what they're doing is thinking of that as a service organization where they can go ask for a report or a number or a dashboard. They're not living it every day. I think with this empowerment of, those data analysts and analytics engineers and data scientists that are embedded in different departments, that does start to get us closer to that first-class citizen. Marketing not only needs dashboards, they can create them. They're not out there asking another team. It doesn't feel as far away. So they are going to invest, again, with that central data team supporting that and that infrastructure. But really it becomes part of every department's goals and needs, and they are empowered, to do more on their own. I think that's where we'll see more and more of this, data really becoming of high value and top of mind for a lot of leaders across the company, not just data leaders. So a little bit more about those central data orgs. Like I said, I truly believe in this model and this concept. And what I really think that is the difference between the central data org of yesteryear and the central data org of today is we need to think of ourselves as enablers, not gatekeepers. It was always, protect the data. What do the analysts need? Tell us exactly what you need, and we'll build out something for you. Taking tickets, moving from ticket takers to more of a vision-oriented product organization as a central data team is really important because, again, all of those different kind of satellite organizations, if you will, not only need to build off of the core infrastructure, but need to work together. There has to be a central org that is in a position to make all of that possible, both technically, but as well as organizationally, ensuring that those teams are talking to each other and that everything is done in at least a similar way on a similar platform so that there is some standardization. So I'm a big believer in this model. A few things about the model, though, I think beyond just being enablers and not, being that service or gatekeeper, is really hiring the right people. I truly believe in hiring data engineers who look like software engineers in skill set, and actually hiring software engineers as well to both, take a lot of these open source projects and integrate them into your data stack, as well as integrate with the rest of your organization's tooling. Sometimes building out your own tooling, right? There might not be a product out there. You might start your own open source project out of some of this work. But if we don't have that capability on the central data team, it's that sort of waiting on engineering feeling again, where we can do everything in SQL, like we can get, a new warehouse spun up, but like we can't integrate that product, or we can't, build out some front end that you might need. We have to go wait for the software engineering team, who is typically very busy building out, your organization's product or some other internal project. So I'm a big believer of those central data teams, not only having data warehouse, people and data engineers who in the past have been a little bit less like software engineers and more, tools oriented, to having that full software engineering capability in that central org. And then again, I think the focus on the core, right? So it's not about building out, individual dashboards or reports or any of those, or even models in the warehouse that are specific to a single part of the organization. I think the more you decentralize and you empower those organizations or those departments in your organization, the more you can focus on those core assets. So for example, every part of the company might care about the revenue that you're generating as a company. And if they each have their own version of that, which I've seen many, many times, there's a lot of ways to define revenue and different cuts. You don't want marketing and sales and customer support having different numbers there. And then finance looking at it going, nope, that's not what we use. So I do think there is an opportunity for central data teams, not just to be software engineers and data engineers, but also that data warehousing component of building out some of those kind of core assets or abstraction layers on top of some of the raw data that a lot of different teams are going to use. And you do want a single source of truth and understanding, as well as ownership of that in the warehouse. So I think it can be both. I don't think it's just moving fully to software engineering. I think we can do both of those at the same time, but also make sure, we're not just going back to creating that silo and that gate. So open source, again, kind of wrapping it up, how does it all fit in? I do think commercial products will still play a big part. I'm not naive enough to say open source is going to take over everything, but I have seen, especially in the last few years in analytics, just an explosion of amazing open source products and projects. Again, you're going to see a lot over the next few days. There's a lot out there. There's so much energy and engagement. We talked about the team culture that it creates. It's amazing right now. And coming from software engineering and seeing, open source over the years, I've been a big believer in it. It's been very successful in software engineering for a reason. I don't expect anything less with analytics. In fact, I think we're even have a more unique opportunity because we are very young in this. We're just starting out and what this data stack looks like. And it's starting with so much open source activity from the beginning that there's a real opportunity there. That said, I know this is a little cheesy, but it really is up to us. We have to look in the mirror and sort of define this future a bit. We are the folks that are doing this. We're implementing these. We're building these open source projects. We're contributing to them. We're supporting them. It's not going to happen without us. So all of these predictions about how data teams will be set up, how the technology will grow, the adoption of open source, the sort of growth of the analytics engineering, as well as data engineering functions, that doesn't happen without us. So really excited to kind of see how this thing grows over the next few years. Really excited to speak today. It's been great. So thank you so much. And please do reach out. I'd love to hear from all of you. Thank you.
Hello, and big thanks to James for the keynote. That was phenomenal. I'm Alex Dean from Snowplow and joined by Brian Leonard from Grouparoo. And we're going to do the introduction section now for the open source data stack. Just a reminder that this QR code, if you scan that, that'll take you through to the Q&A that is happening over on Discord right now. So, okay, so we've all been to a few data events, expos, conferences, and there's a bit of a problem with a lot of them. And so with apologies to shit user story, here's a user story. As a data practitioner, I want to learn about a bewildering array of new technologies, each presented as the one true answer to all my data-related problems, so that people buy more stuff on the internet. We've all been to those conferences. We didn't want to do another one, so we're going to do something slightly different here. So what are we going to do? We're going to start from the use cases. So first, we've invented a fictitious company that is looking to drive competitive advantage through data. Then we've identified 2 business critical use cases that depend on this data. And then 3, we then show how these use cases can be solved using open source vendors across the modern data stack. So we're taking a use case centric approach. Brian, over to you.
So let's meet our company. We've got not a real company, but it's called Yukon. I made this up because it's my understanding that all great e-commerce companies are named after rivers and mountains. In this case, it's a global e-commerce company looking to use their data to get that advantage that Alex is talking about. They sell a variety of things across various categories. They've got a growing team of data analysts, engineers, analytics engineers, data scientists, all striving to turn that data into a product and give them that advantage. And while you might not work for this fictitious company, I think you'll be familiar with the challenges that they have. Let's talk about, getting real specific about the tools they're using. You probably use something similar in each of these buckets at the very least. They've got a data warehouse. They're using Snowflake. They've got a transactional database where they're storing their users and their purchases in Postgres. They're using Zendesk and Marketo for their support software and email, respectively. And of course, like all great e-commerce companies, they've got ads in everywhere they can put them, specifically in Google and Facebook. And what do they want to do? Well, data can do a lot, but they specifically really are focused on understanding how their business is doing through the metrics that matter to them, using that to drive decisions. And 2, they're looking to enhance the customer experience for Yukon's big spenders. So how can we give the best experience to the people that are driving the most revenue to our company? All right, let's talk about their key metrics. Probably not that different than the ones you have at your company. They're interested in their users and their lifetime value. Who is active? How do they retain them over time? How engaged are they? What sources of getting those users is working and not working? The quality of their experience and their product that they sell, as well as what products are selling most effectively on their site. Let's talk about how they're trying to make those high-value users experience better. First, they want to understand who they are using this data. Then they want to enroll them in a rewards program. They want their help desk tickets to be answered more quickly, get the best possible experience. And then they want to remind them of the offers related through that ad network that I was talking about, that Yukon is great and you should buy more stuff, because that's the goal, of course. To do that, we have some great vendors from the open source data world here today, walking through this pipeline that James talked about. We're getting events from Snowplow. We're getting data in from our transactional database and tools from Meltano. We're transforming that with dbt. We're visualizing it with Superset, and we're syncing that back to those tools, reverse ETL using Grouparoo, coordinating all of it with Dagster.
Thanks, Brian. And so, yes, building on that open source diagram of different tools, each of our speakers today will explain how Yukon uses their specific open source tool to meet their goals. And so we've got the schedule up on this slide. We've also got the schedule up on the website. Check out all of these talks. They're all great, and they'll help explain how a company like Yukon uses all these tools to drive their business forwards. Thanks, everyone. Thanks, Brian.
Thank you. Look forward to a great conference.
All right. Thanks, James, for an excellent keynote speech. My name is Alex Dean. I'm CEO and co-founder of Snowplow. And I'm really excited to be kicking off with the first of the vendor-specific talks for the Open Source Data Stack Conference. Let's get started. Just as a reminder, we have a Q&A taking place over on Discord. You can use this QR code to jump into that chat. Okay, so the Open Source Data Stack Conference, we're trying to do something a little bit different here. We're trying to come up with a fictitious company called Yukon, and we're trying to show how various different open source vendors that are part of the modern data stack can come together to help solve use cases for that vendor. And so I'm from Snowplow, and we're all about getting behavioral data into the data warehouse to power use cases. So before I start talking about Snowplow and what we do, let's do a bit of reorientation around Yukon. Yukon is a fictitious global e-commerce company. It's looking to compete through sophisticated use of data. It's very diverse. It sells across a bunch of different categories, including kids, books, games, tools, jewelry, all sorts of stuff. Has a modern data team, and its digital estate consists of an e-commerce website built on Ruby on Rails, a mobile app built on React Native, and emails that are sent out to customers and prospective customers via Marketo. So that's Yukon at a high level. So it really goes without saying that a global e-commerce vendor like Yukon is going to generate an immense amount of data. So that data is going to be across finance, across sales, across stock, production, customer data, logistics, partnership data, all sorts of different things. It's just the nature of things these days. And some of that data, so the customer data is a big pot there. And then within customer, you're going to have things like CRM data, email lists, surveys, focus groups, and you're going to have this type of data called behavioral data. Now, what is behavioral data? Well, simply put, it's data that describes how the shoppers or prospective shoppers at Yukon are going to behave. So it's collected as event data from Yukon's digital platforms, such as web, such as mobile, such as email. And this is a really enormous data set, which presents some really great opportunities, but also some real challenges. I think the other thing to say about behavioral data is it's both broad and deep. So it's very broad. It covers a lot of different activity that you'd be interested in about your customers, but it's also very deep. It can be very, very granular. It can give you a really deep insight into what your customers are doing. So if we think specifically about the behavioral data that's going to be generated from Yukon's digital properties, it's going to be really, really rich. And I've got some examples here. So examples like opening an email, changing your account preferences, selecting garment sizes, viewing recommended search results, filing support requests when you're having a problem with the Yukon site, and of course, checking out from the online store. So if we think about across website, across mobile, across email, there's going to be a really, really rich, broad and deep granular stream of behavioral data coming out of Yukon's digital properties. So having given that framing around behavioral data and what it is, let's return to the kinds of problems that Yukon wants to solve with this data. So if you remember from the previous session, Yukon is looking to understand their key metrics, and Yukon is also looking to enhance the customer experience for Yukon's big spenders. And the exciting thing here, and this is why I'm talking to you today, is that behavioral data can help power both of these really important use cases for Yukon. So if we take the first use case, if we take understanding Yukon's key metrics, we've got a list here of key metrics and we've got descriptions of them. And what I've done is I've taken the parts of those key metrics that is only available by collecting the behavioral data from Yukon's customers, and I've highlighted that in purple. And so really the ones that I haven't highlighted in purple, it would be possible to pull those out of transactional systems, for example, using Meltano. But the pieces in purple, you need to have a technology like Snowplow active in those digital properties, really kind of collecting and generating and collecting that behavioral data. So to give those specific examples on this slide, retention. So the activity of users on the site is going to be very important to track that track those digital footprints on their website. On email, the same thing. So whoever's opening emails, you're going to typically track that using a kind of a pixel inside the emails that will send that data into Snowplow. Same with ads. So you can add Snowplow tracking into an ad unit, and then you can see when a shopper or a previous customer or a prospective shopper last interacted with that ad unit. That last one, product conversion, so product look to book ratio, is quite an interesting metric. It's essentially the ratio between how much people are looking at a property, at a product inside the shopping catalog versus actually adding it to cart and then buying it. And so those essentially product impressions, so how many times those products are being looked at, again, is something you would track through Snowplow. So what you can see from here is an awful lot of Yukon's key metrics need to be very heavily informed by the behavioral data, so how the customers and potential customers are interacting with Yukon's digital properties online. The second use case, remember, this is enhancing the customer experience for Yukon's high-value customers. And the essential idea here is that we identify those high-value customers, and then we're going to do a few things with them. So using Marketo, we're going to enroll them into the right rewards program. Using Zendesk, we're going to make sure that their help desk tickets are answered more quickly. And we're also going to remind them of offers related to their recent purchases on Facebook. And so this whole use case is going to lead to a great session later, where Brian is going to explain how to activate these things using Grouparoo. But in the meantime, it's important to stress that the behavioral data that we've talked about is going to really, really help identify Yukon's high-value customers. So we can use these behavioral signals around interactions with the site, interactions with the mobile app, behaviors on email. We can use those to inform who are the most valuable customers, who are the ones that are showing really promising behaviors that should be activated using reverse ETL later. So I've done a bit of a framing here. I've talked about Yukon, I've talked about the use cases they want to solve, and I've given a brief introduction to behavioral data. The next piece to answer is, well, what is Snowplow? Simply put, Snowplow is a batteries included behavioral data engine. It includes tracking SDKs. It has a schema registry for data quality. It has enrichments to make the behavioral data richer, more easy to analyze, and it has powerful loaders to get that behavioral data into different data warehouses. It's essentially an open source data processing pipeline. So what does Snowplow do? It loads that behavioral data into Snowflake, Redshift, and BigQuery. We're focused on Snowflake for Yukon. That's their cloud data warehouse of choice. And it supports other destinations as well. So before we get on to the other destinations, in terms of the warehouses, I've updated the core diagram for the conference with this set of the warehouses. Essentially, Snowplow is sitting in between the Yukon digital estate and the data warehouse, and it's essentially streaming or kind of micro batch loading that data into the warehouse pretty fast. In terms of the other destinations, so Snowplow also supports S3, Postgres, Kafka, Kinesis, Google Cloud Pubs Hub, Elasticsearch, and a handful of others as well. But that's where we sit inside the stack. And an important point as well, given the upcoming talk from Julia at DBT, Snowplow is all in on DBT. So DBT models reduce the time to value in building analytics and data products for companies like Yukon on top of our behavioral data. We have a DBT model for Snowplow behavioral data that comes from websites, and we're working on a second DBT model for the Snowplow behavioral data that comes from mobile apps. And you can see one of the Snowplow models featured in the DBT hub on the right here. So yeah, we see DBT as a very important part of taking that very granular data that is landing in the data warehouse and essentially aggregating that up, layering it up, and making it a bit easier for analysts, data engineers, analytics engineers, and so on to work with. Okay, so this is an open source data stack conference. Snowplow is open source. We've been proudly open source since we launched the project back in 2012. Snowplow is available under an Apache 2 license. We launched Snowplow originally to make this kind of technology, this idea of a kind of a behavioral data engine, accessible to far more organizations. So back in 2012, when Yali and I started the project that then evolved into the company, we'd been doing analytics projects for clients in the UK, and they had access, they'd been able to share with us very granular transactional data from their own customers. So for example, extracts from CRM, ERP, that sort of thing. But when it came to how their customers were interacting on their websites, they didn't really have that much. So they would say things like log into Google Analytics and get what you need, but that wasn't what we wanted. We wanted that super granular kind of behavioral data that I talked about earlier. And from various projects we've done before 2012, we knew how to build that technology. And so that's what we then turned into the original release of Snowplow back in 2012, running cloud native on AWS and Apache 2 license from day one. And so our goal really was to get it out there and say, you know, you don't need to have a big data engineering team that builds this stuff themselves. You could be a much smaller organization, but very data ambitious, data curious, and just download our software from GitHub, run it in your own AWS account, and start to kind of work with this very granular data. And so I guess another way of putting that is, you don't need to be a Yukon, you don't need to be, you know, a global e-commerce business to be able to work with Snowplow. You can download it and go from there. I think a few other points about open source are really important to stress as well. So to us, open source and the open source data stack is very important from a data sovereignty perspective. So this is an important point to make. The data flowing through Snowplow, it is your customers' behavioral data. It is not Snowplow's data. So we just see ourselves as a software vendor. We've built this great engine. You download it, you run it. Even when you're a paying customer of Snowplow, you're not sending any of that data to us. We're not kind of in the middle in any way. I think another really important point about open source, and this I think will come up in the other talks as well today and the rest of the week, is it really does help increase assurance. So as a data team or data practitioners who are working with Snowplow or other open source data stack tools, you have that ability to go in, audit or inspect all the data processing code. So you can go in and understand how it's working. You can understand what the different edge cases are, how it handles them. If data's not being processed in the way you expect, you can go in and look at the tests and try and understand why. So it really, really helps when you're trying to build, you know, serious business critical data products and, you know, maybe financial reporting on top of this kind of data or whatever it is. It's really, really important to have that assurance. Another thing that's really important is, of course, encouraging those kind of long tail code contributions. So at Snowplow, we can't build everything. There will be features, there will be enrichments, there will be destinations that people want Snowplow to support that aren't up there on our roadmap. And so open source makes it possible to do those things. And I think going further than that, the whole architecture of Snowplow is very modular, very protocol oriented. And so it's quite easy to plug into the Snowplow architecture at different points along the way and go from there and kind of add your own functionality in there. Last but not least, I think this is an incredibly important part of open source. It really does help remove the risk of vendor lock-in. So, you know, there are some great and very successful proprietary technologies in the modern data stack, but all the open source ones really do kind of give you that confidence that the software will be around for a long time, that it will continue to be permissively licensed, and that you can build your analyses or your data products or whatever else it is that you need to do as a business on top of your data with some confidence. And Snowplow, as an example, we've been around since 2012, so coming up on our 10-year anniversary, which is pretty cool. So I wanted to also flag that we have a commercial version of Snowplow called Snowplow Insights. So if the open source is great, but we've also developed over the last few years a kind of a studio UI to help solve the organizational challenges of working with this behavioral data at scale. So as you become a larger company, as you start to face some of the challenges that are you know, a big brand like a Yukon would face, you start to see these interesting challenges with behavioral data. And this is what our kind of Snowplow Insights and the UI within it can really help tackle. So there's a screenshot on the right-hand side of part of the data quality interface of Snowplow Insights. And then on the left, some of those kind of questions, gnarly questions that data practitioners, data teams, data consumers, data producers might find themselves asking, like, how do we decide what behavioral data to collect, and how should that data be structured? How do we rapidly iterate our behavioral data collection to meet our evolving needs? How do we build assurance in the accuracy and completeness of the data? Another thing that's quite interesting about Snowplow Insights is that it's sold as private SaaS. And don't worry, I'll explain what private SaaS is, but I think it's a great model for open source data infrastructure. Fundamentally, private SaaS is software as a service. So Snowplow Insights is sold as a software as a service offering, but it runs behind your firewall inside your own VPC. And so this is really important. It means that the behavioral data never leaves your AWS or Google Cloud sub-account. That means that you retain your end-to-end data sovereignty, even if you're a paying customer of Snowplow. We deploy, monitor, scale, and upgrade the underlying Snowplow technology for you, so it stays up to date and it stays highly performant. And that pipeline, that kind of underlying engine, sitting inside your own sub-account, then communicates back to our centrally hosted Studio UI. And I've got some logos here of Snowplow users and Snowplow Insights customers. So, okay, so we've talked a bit about the use cases that Yukon has. We've talked a bit about behavioral data. We've then talked a bit about Snowplow itself, both the open source version of Snowplow and the commercial version. How would a company like Yukon set up and use Snowplow? Let's talk about this for a few moments. So first things first, Yukon would define schemas for specific events like add to cart and specific entities like perhaps apparel product. So what do we mean by this? The events are the things that capture a specific action that a customer or potential customer has taken. So add to cart is a great example of that. And then entities describe almost the business records, the business entities that are important to Yukon. And those will be structured out, and those entities can be added in alongside the events during the tracking process. So fundamentally, having defined those events and entities, those definitions will be added into the Snowplow schema registry. The next step will be to implement tracking across web and across mobile using our SDKs, and also probably add pixel tracking into the emails. That tracking will be done by the front-end application teams, and they'll make care when they're doing that to send in the right events and the right entities into the Snowplow pipeline as they're going. Once that data is flowing through into Snowplow, there's then a bit of configuration to be done on the Snowplow pipeline, for example, configuring the enrichments that will add extra data points to Snowplow. And then you'll go into the data warehouse and deploy the DBT models that will take that very granular behavioral data that's landing in Snowflake and then do further processing on it, add kind of essentially extra aggregation layers to it to make it easier for analysts and engineers to work with. And then that will be the final step. So working with the Snowplow data in the data warehouse in Snowflake. So we talked a bit at the top about behavioral data, and I've just mentioned this idea of defining events and defining entities and sending those through into the pipeline. I wanted to give you a sense of kind of what that means and why it's a little bit different from some of the perhaps event tracking technologies that you might be familiar with that grew up over the last 10 years. So I've got a sample on the right-hand side of a potential Snowplow event that Yukon would send in. The data is a JSON payload, and it is sent in, as you can see here, with a reference to the associated schema. That schema is namespaced, so you can see that it belongs to com.yukon, and it's also versioned. And that's really, really important because that versioning allows the Yukon team to evolve their definitions of these structures of these events and these entities over time. And the way that Snowplow works is you can be sending in different versions of those events and entities simultaneously at the same time. So Snowplow can kind of progressively, gracefully evolve different data structures that you're sending in as your understanding of the business problems you're trying to solve evolves. Now, as well as the event JSON that I'm showing here, remember that an array of associated entities could be sent in as well. So for example, an entity that's describing the current shopping cart could be sent in with every event that's relevant as well. Now, all of this data flows through into Snowplow. It gets validated and it gets stored in the data warehouse, in this case in Snowflake, in a Snowplow curated activity stream table. So what do we mean by validation? Fundamentally, when these events land in the Snowplow pipeline, Snowplow will go and look up the schema definition from the registry, the schema registry, and it will cross-check the data that it's received against that registry schema. If it passes, so if this data payload matches the schema definition, then the data will be flowed through into the warehouse successfully. If the data is corrupt or it's invalid, then it will be moved into a separate flow, into kind of a bad bucket, if you will, a bad stream for further processing and, for example, for event recovery. So Snowplow, it's very important to Snowplow technology that all of the data that flows through is kind of properly validated, but also that it's possible to recover data that's incorrect or invalid for further processing. So, okay, this is exciting, hopefully. How do you get started with Snowplow? So there's two options. So the first is spinning up our open source, and the second is our hosted free trial. There are other options as well. You can deploy a full fat pipeline and things like that, working through all the different components in our GitHub, but I'd really recommend starting with one of these two. So first is spinning up our open source using the open source quick start. So what is the open source quick start? It is a set of Terraform modules to easily set up a Snowplow pipeline on AWS for destinations. So destinations that the quick start can load the behavioral data into. It supports Kinesis, S3, Postgres, and Elasticsearch. At the moment, the quick start only sets up the pipeline on AWS, but we do have support for Google Cloud Platform and BigQuery coming soon. So watch the space. And I would say that the open source quick start is a really good gateway for setting up a Snowplow production pipeline, open source pipeline, which would allow you to load S3, Redshift, Snowflake, and things like that as well. So that's the first option. The second option is our hosted free trial. So we just actually launched this a week ago. It's called Try Snowplow. You can find this on our website. It's easily deployed in 5 minutes. It doesn't require you to have an AWS or a Google Cloud Platform account. And this one is a really good fit for data analysts who don't have experience in DevOps, maybe don't have access to a cloud account yourselves, but you do want to learn about the Snowplow data, and you do want to understand kind of how rich that behavioral data is, and why it's a very powerful thing to work with and build data products on top of, very rich analyses and so forth. Try Snowplow is a good gateway into our commercial products, Snowplow Insights. It's also a good gateway into potentially taking this demo, this trial, and showing it to data engineers or DevOps practitioners in your organization, and showing them kind of the potential of Snowplow. All right. Well, look, big thanks for listening. You can ask any questions over on our Discord, and you can certainly reach me on the below. So like I said, I'm CEO and co-founder of Snowplow. You'll find me on Twitter as Alex C.R. Dean, not super catchy, but that's me on Twitter. And there's my email at Snowplow as well, if you want to drop me a note. And just a reminder that we have the Q&A taking place over on Discord at the moment. And so, yeah, big thanks for that. And hopefully with this talk, you can visualize now why behavioral data is really important to UConn, and how Snowplow plays an important part in the open source data stack, generating and then delivering that behavioral data into Snowflake for UConn, ready for DBT to pick up the workload. In parallel, you're also going to have a technology like Meltano that's pulling in other data, transactional data fundamentally, from databases, from SaaS tools, and getting that into the warehouse. Having that Snowplow plus Meltano data all sitting in the warehouse together is going to set you up in a very powerful way for downstream analyses and helps UConn with its use cases. So do check out Taylor A. Murphy coming up next from Meltano talking about ELT. Thank you, everyone, and goodbye.
Hello, everyone, and welcome to my talk. Thank you so much for joining. My name is Taylor Murphy. I'm the head of product and data at Meltano. I've been asked to direct you over to the Discord where there's a live Q&A taking place. You can just scan the QR code. Hopefully you've enjoyed the talk so far, our keynote from James Densmore and the talk about Snowplow from Alex Dean. I'm here to talk about Meltano and more specifically extraction and loading within the context of the open source data stack. I'm sure you've seen this slide. Everybody's going to be talking about it. Meltano fits in here. We are focused on extraction and loading. So getting your data from databases, internal, external, third-party SaaS APIs, different files into your data warehouse. Of course, this is all in the context of this fictitious company, Yukon. They're a global e-commerce company selling a bunch of stuff. But most importantly, I think for this talk is they have a data team. Data analysts, engineers, analytics engineers, data scientists. I'm guessing a couple of managers as well, since that's a lot of people not to have a manager. And they're all working together on a shared mission. And this is really great news because if they have a data team, that means you can assume that they do have some support at the executive level. And I'm kind of making some of these assumptions, but I think it'll help the talk. We can assume they have some funding, but probably not enough to go full beans. They couldn't go buy just whatever they wanted to. And I'm also going to assume that the team is kind of getting off the ground. Maybe they hired a bunch of people in, or they're really starting to take a hard look at how they want to grow the data platform and the data product. And they're making some immediate build versus buy decisions. There's two more things that I want to highlight and get out there for the purpose of this talk. One is, what is the purpose of a data team? And the other is how to frame how data teams work and how to think about how data teams work. These next 2 points are taken from a talk that I gave with Emily Sherio at Coalesce 2020. And so if you attended that talk, you'll see some repeated themes, but I think it's good to highlight here. What is the purpose of a data team? We had posited and still think that the purpose is to help organizations make better decisions. Everything that a data team is doing should be focused on better decision making, whether it's building models, building reports. It's all in the end about getting that information and making a decision from it. Now, how should a data team work? Well, looking at this conference in particular, and then the conversations that are happening around the modern data stack, we see data teams as building a data product. They're building products and adding tools to the tool chain to achieve the outcomes of the goals of the team, which is to help the company make better decisions. But what is the data product? So the data product is every piece of data that is flowing between people, systems, and processes. Every analysis that the team is producing, every dashboard, every BI tool, but also every tool that has some sort of analytic capability built into it, such as Zendesk or Salesforce, that is part of the data product. Every spreadsheet, every CSV, every Google Sheet, that is also part of the data product. And you can think about all of these things as feature sets of your data product. But more simply put, if people are using it to make decisions, it's part of the data product. Now, what isn't part of the data product? Well, one thing that isn't part of the data product is individual pieces, in that the individual piece is not the data product in itself. You can't look at your data warehouse and say, this is my data product. That's not it. The warehouse, the BI tool, the data platform, they're all part of the product. The main thing that's not part of the product is the myriad other jobs that your colleagues are doing within your organization, whether it's talking to customers, responding to support tickets. They may generate data that winds up as part of your data product, but those jobs in themselves are not part of the data product. So why are we framing it this way? Well, we've taken a look at a lot of great companies, and a lot of them are product-led organizations. They have really good products, but they also have really strong product teams. These teams are made up of a diverse array of people with different backgrounds and skill sets, and they're all coming together to focus on solving customer problems in the best and most efficient way possible. Good product teams have a vision and a strategy on where their product is going, and they also drive really good business outcomes for the organization. Revenue in the case of for-profit enterprises, but also driving towards the mission and vision of the organization. And we want all of this for data teams as well. We think data teams should have a clear vision and strategy. We believe they should have a deep understanding of their customers, who in this case are your coworkers. We think teams should have a lot of great people with a diverse set of skills. And we're seeing this today with the rise of analytics engineers, machine learning engineers, data product managers. All of this, and with all these great people, you can think of yourselves as working to iterate on the feature set of the data product rather than being stuck in the service model. And again, all of this is to empower the company to make the best decisions possible. So as a data leader, and I include everyone that's on the data team, certainly for the purposes of this talk, as a data leader. If you're on the data team, you have a skill set, you have opinions about how data should be used and transformed. So in that case, you are a data leader, and you can help guide the strategy and feature set of the data product. So with all of that out of the way, let's get back to UConn, who is building their own data product, but more importantly, they've got their own set of questions that they're trying to answer. They've got a set of metrics. And this is a really exciting thing to see. The company has, the data team has taken the time to engage with the business to ask tough questions about what is important to measure, what do you care about, what decisions are you going to make, and they come back to the table with this set of metrics. And with this in place, and we could debate all day whether these are the right metrics, but let's go with this assumption that this is what we're using. From here, you can back solve to what data sources are we going to be pulling from to actually answer these questions. And so these are the tools that UConn is using today and what we're pulling from. We know we're going to Snowflake as our data warehouse. We're pulling from a transactional DB, in this case, Postgres. And then we've got a variety of different SaaS tools such as Zendesk and Marketo, and then some ads tools as well for Google and Facebook. Okay. So with all the groundwork out there, we know what the data team's doing, what its purpose is, we know where we're aiming for, we know what tools we have. All of the requirements are in place, and let's go on a journey. And be warned, this journey has a lot of gifts with it. So let's have fun with that. So we're going to leap 3 years into the future with UConn. What do you think theirs, and really your, extract and load requirements are going to look like? Do you think they're going to be almost identical to where they are today? Probably not. What are some things that are going to be true 3 years from now? Most likely, you're going to have some really strict security, privacy, and compliance requirements. As organizations grow, this tends to be the case. You get compliance people, auditors in there. There's just going to be a little bit stricter control around everything that you're doing. You're probably going to have a larger team, but you may have a tighter budget as well. Financing doesn't always scale one-to-one with headcount. You're certainly going to have more mature processes, whether that's internal to your data organization or within the organization more broadly. There's just going to be more things you have to do to get things done. Perhaps there's more sophisticated tooling across engineering and other organizations. And I think most critically, your data sources, or rather UConn's data sources, are going to grow from this small set to this and then some. You're going to have more third-party tools. You're going to have more databases. You're certainly going to have some spreadsheets that you're going to have to pull some data from. There's going to be a diverse array, and you don't know upfront what you're going to have in the future. So with all this in mind, thinking forward into the future, what's the worst that could happen? What's kind of the worst outcome if you make a decision now? What could be some of the effects of that decision 3 years down the road? Well, in my mind, this is kind of the worst case scenario. You wind up with a tool or stack that doesn't support all of the weird APIs, databases, and files that you're going to absolutely have. You're just going to have a bunch of different sources, as I mentioned, and if your tool doesn't support it, you're going to be in some trouble. Another bad outcome would be that your tool doesn't work well with your existing stack or processes, whether that's integrating with the tools that the software engineering team is using, or if you've made decisions about other tools, if it doesn't work well, that's going to be a big challenge. Another potentially bad outcome is that to add more data sources, you need to negotiate a new contract. That's not fun. As I mentioned, the security, privacy, and compliance concerns, particularly around internal databases, may become a concern. I saw this at GitLab, where we're trying to pull data from an internal database and having to go through the machinations to actually make that happen and stay within the boundaries of security, privacy, and compliance. Then another potentially bad outcome is having to engage with a support team that maybe is not as helpful as you'd like them to be, maybe because you're on a lower tier, maybe the company that you've chosen to work with doesn't have a great support team, but in either case, it's just kind of a one-to-one relationship. You have to go to them and wait for them to help you. This is bad. This is not a great outcome. Some would say this is the worst. So let's flip the script. What's the best that could happen? What's kind of the best case scenario? And really, I think it's just the opposite of the worst case. You have a tool and a stack that does support a diverse array of data sources and weird APIs. Your tool is flexible and can integrate well with your existing stack and with stacks that you may not even be aware of exist in your company. There's just no need to have these extra negotiations for additional sources. You've solved and ameliorated all the challenges that you're seeing around security, privacy, and compliance, all within the same tool. And I think the most exciting best case scenario for me is you now have a support community that is extremely helpful. Instead of having a one-to-one relationship with the business, you're able to connect with users and other people in your profession and in the ecosystem to gain help and to solve your problems. Okay, so how do we get there? How do we go? How do we make the small decisions? And what do we need to be thinking about to avoid the worst case scenario and achieve the best case scenario? I think it comes down to 3 key attributes that I want to talk about for the rest of the talk. Those are open source. This being the Open Source Data Stack Conference, I think that's kind of obvious, but I want to dive in and explain why that's important. I think a standards-based approach is also going to be critical, particularly for the extract and load phase of your data stack. And then I think having a data ops first mentality is very critical and will become more critical in the intervening years as data teams grow and as we all become better at doing this job. So let's start with open source. Why open source? And I kind of teased it at the end of what's the best case scenario, but open source generally is all about community. In the way that people work, when you're able to be transparent and open about what you're working on, how things work, where the code lives, where the issues are, who's working on it, it invites people in. And we see, I think the best example of this by far is of course, DBT Labs and DBT, the product. They've built a great product that is open source, that invites people in, and they built one of the best communities in the data profession for getting work done. And I'm excited for you to hear more from Julia tomorrow about DBT. Open source also is more accessible, and this ties back to community. But by being open source, and typically there are free versions of these products, even if there's a paid offering, by having a free version that is open source, it invites more of the world to be able to use the product and to benefit from the best practices. We've seen at Meltano that there are places in the world that don't have the resources that we do and maybe can't afford to pay the prices that American companies want to charge. And so by having an open source product, you really unlock that access for folks to engage in the best practices of their profession in the current day. And the last point about open source, which I think speaks to the flexibility of a given tool, is the fact that the code is open. And generally this means that the tool is going to be fixable, it's going to be debuggable, and it really empowers you and gives you control. When you can see the code, when you can understand stack traces, when you can deploy it yourself, it empowers you to understand how it works and to fix problems when you see them. And you can also deploy this in your own environment. You aren't stuck with what one company says you have to do. You can put it wherever you need to. And so it is very empowering and kind of gives you that control back. So given that you're at this conference, I won't belabor the point that open source is an important part of the decision-making process for any given tool in the modern data stack. Let's dive into standards-based. Why is a standards-based approach important? I think the first thing, and I'll spend a few minutes on this, is that when there is a known specification, if you are able to build to the spec, you know that it's going to work. In the context of extraction and loading, this is really, really powerful. If you build a connector for a given database and you say, this is how I expect all the data to come in, and you put that out there in the world, suddenly you can build thousands of connectors that can all feed into that one target, that one connector into that database. Now you're able to collaborate with a worldwide audience that are using very similar products. You're going to have a large catalog of connectors to work with, and you just know that it's going to work because all you have to think about is kind of building to the spec. And it really creates the opportunity to solve a lot more problems than any one organization could. No one company is going to be able to build every connector that you need, especially if it's in a point-to-point from one database to one API and on and on and on. You build to a standard and it allows everything to funnel in. Standards are really good. We've seen this with SQL in particular, and again, referencing DBT Labs. They standardized on SQL, and that has just unlocked a huge amount of collaboration and community. And speaking of community, again, it brings more people in. When there's a shared standard, you don't have to really argue or debate about like what is the standard. Of course, we do that. There are ways everything can be improved, and that is a part of the discourse is improving standards. But it allows you to get work done and focus on solving more interesting problems, and also allows you to share that work. And sharing that work means that it's reusable for a lot of people. As you move through your career to different organizations, you're able to carry those tools and also that experience to different organizations. You're not locked in because you've gained your chops on one specific tool. If you build something at one place, if it's open source, you can take it to another place. This is really powerful for organizations, but also for you as an individual. And I think it does speak to the power of open source and standards to really enable your employees to be really happy, because they know that they're not learning something that's just going to go to waste if they ever have to leave your company. So we're talking about standards, but I'm not talking about SQL. So which standard for extract and load are we talking about here? Well, the one that we really believe in as Meltano is the Singer open source standard for moving data. It is the de facto standard for moving data at this point. It was launched in 2017. It is currently in use by fantastic companies and a fantastic community around the world. It by far has the largest Slack community with over 4,000 people in the Singer Slack alone, and that's not including any of the supporting Slack groups such as Meltano's. This screenshot here is an example of what the data looks like according to the Singer spec, but really it's not important what the spec actually looks like. Just knowing that it exists and that you're able to write to it, and we've built some tools to make that easier, is where a lot of the power comes from. And the assertion that this is kind of the de facto standard is supported by Singer having the most connectors in any sort of data movement ecosystem by far. This 300 number is counts both taps, so pulling data from different sources, and targets to where you want to push the data. And we've helped catalog a lot of these, and we see new ones being built every day. And there's some from APIs that you've never heard of, and there's some that we haven't even cataloged quite yet. People are very active in this community, and it's one of the better ones out there. And like I said, it's a large community. We all have data movement problems. We're all solving similar problems. And we hear every day that people are excited to be a part of the Singer community so that they can solve their problem and then move on to more challenging and more interesting problems. But they also get to work with a wonderful community. Okay, so we've talked about open source and standards-based as two key attributes for how you should make your decision. The third one I've highlighted is a data ops first mentality. So why data ops? Well, before I get into what kind of data ops is, briefly, in our view, when you combine open source tooling with a standards-based approach to working, we really do think that it unlocks this improved way of working together. We've seen this in software engineering, where open source tools, standardizing on tools like Git or protocols like Git as well, have enabled better outcomes for software engineering teams. And we think that's possible for data teams as well. So data ops generally, there's maybe some debate about what exactly it is, but we tend to view it in kind of this lens. And some of this is taken from the Data Ops Manifesto. If you go online and check that out. But the big things to keep in mind about data ops is the framing that most everything that an analytics team is producing is code. If you're writing SQL, if you're generating some YAML, if you're dealing with some Ginger or something crazy like that, you're writing code. I don't want to be exclusive. If you're writing Python, Scala, R, that's all code as well, and you should think of it as code. Another big benefit and assertion for data ops is this idea of disposable environments. One of the things about disposable environments that's really nice is when you're able to spin up a testing or a staging area, you can test your workloads, your analytics, make assertions about data quality. And then once you're confident that everything's good, you destroy that environment and you can release your data to prod. This gives you great confidence in what you're doing. Data ops also implies a level of reproducibility and reuse in your code and in your work. And all of this is in the framework of the assumption that data and the questions that people have are going to be more dynamic and they're going to be continuously changing. The questions that people ask are going to be changing, the decisions that people are going to make are going to be changing, and that all implies that down to the bare level that schemas are going to change, the data itself is going to change, and that your tooling and the ways that you work need to be able to handle that and be dynamic and support that. So with this in mind, like we at Meltano really believe that what DevOps has done for software engineers, data ops will do for data professionals up and down the stack. And all of it really is with the goal of enabling everyone to collaborate confidently on this data product. So you know that when you want to make a change, that what effect it's going to have, that you can test that out in a safe place, and that you're going to affect things in a positive way when you actually push a change into production. And like our good friend Bill Nye here says, if we think together, we work together, good things are going to happen. And we see data ops as really bringing that to life. Okay, so these are really the three key attributes for affecting a positive outcome when you're making a tooling decision: open source, standards-based, and data ops first, because all of this is feeding into the data product. Remember, we want to achieve that good outcome, and all the folks here at this conference meet a lot of these criteria and are excellent choices for any stack. And again, this is in the context of solving a business need. We're not just doing this just to pick a nice tool that's fun to use. There are questions that people have that we want to answer, and the data product that we're building should be able to support that and make our customers, make our colleagues happy. So by choosing a tool that's open source, that's standards-based, and is data ops first, you're building a strong foundation. And when you have a strong foundation, that means you're achieving this best case scenario. You're achieving a tool, or you have a tool that's able to support a bunch of different APIs. It works with your stack because it's flexible and you can iterate on it. You control it, so there's no need to negotiate new contracts just for additional data sources. You're going to have stronger security, privacy, and compliance outcomes because you're able to control where you deploy it and you're able to understand what's happening. And again, with the open source data stack, you're plugged into a wonderful community of smart data professionals that are solving similar problems and can help you solve your problems as well. And when you have a great foundation and you're at this best case scenario, your stakeholders, your users, and your colleagues are all going to be super happy and thumbs up. So, of course, we think that being Meltano, that Meltano is a great solution for your extract and load. But even more than that, I think Singer, as I mentioned, is a fantastic open source standard for moving data. There's a large community there, and you can run Singer outside of Meltano, but we do think Meltano is a great way to run these different taps and targets and configure it and version control it all within a single repository. If you're interested in more, meltano.com is the website. We are hiring. We've got a lot of great job openings. We also have a wonderful Slack community. You can go to meltano.com/Slack to check it out. You can follow us on Twitter at Meltano Data as well. This is a quick headshot of the team. The whole team got together in Mexico City in July. Our CEO, Dao Aman, lives in Mexico City, and we all gathered there to get to know each other. We're all vaccinated, so it was a wonderful time, and probably one of the first times all of us have been able to get together since last year. So if you want to come join this wonderful team, come check out our website. Again, my name is Taylor Murphy. I'm at Taylor Murphy on Twitter, or shoot me an email, taylor@meltano.com. Thank you so much for your time and attention. Hope you enjoyed it, and hope you look forward to hearing from wonderful people tomorrow. We've got Nick Strock up first, who's going to talk about Dagster. So thank you everyone for taking the time, and I'll talk to you later.